with the sound of the ocean like lapping against the dome. And I took a big breath, and I saw, like right in front of me, this huge eyeball staring, unblinking, right at me.
Oh, Jesus. I get weirded out. I get weirded out just you saying that. 2 weeks at the bottom of the ocean?
Yeah.
The Pacific Ocean is home to several mysteries, some of which we are content to ignore as humans. The region has been largely synonymous with beautiful landscapes, doing a great job of hiding some disturbing realities, from radioactive contaminants to plastic pollution. One of such is the massive geologic activity around Mount St Helens. The US Geological Survey has just uncovered terrifying occurrences underneath the infamous eruption site, a leak in the ocean floor surrounding Mount St Helens. What are the causes of this leak, and why are scientists so worried about the consequences for the immediate ecosystem and the future of our planet? Nature of North Pacific leaks. Before we explain the causes and effects of this terrifying leak, let's go all in on what the leak entails, its nature, and how it was discovered, as this will help shed more light on what's happening and give the necessary background info for anyone who's finding out about this for the first time. Mount St Helens has been a subject of close monitoring for many decades, but it was the catastrophic eruption in 1980 that informed the constant watch it is under now. It is an active volcano located in the Pacific Northwest region of Washington in the United States. The volcano has a peculiar history, one which, when combined with the specific location, calls for undivided attention. That's because it's located on a key area of the Earth's surface, known as the Cascades Volcanic Province. This is an arc-shaped area existing parallel to the Pacific coastline and extending from northern California to southwestern British Columbia. It is one of the most tectonically active regions in the world due to its unique geochemical composition and the volatile reactions going on in the zone. It consists of a dense oceanic plate underneath the North American plate in a process known as subduction. When this oceanic plate takes up deeper positions under the Earth, water molecules are trapped within rock escape due to the high temperatures and pressures. As the water escapes, it moves upwards into the outer coverings and causes it to melt, forming magma, which also travels upward by taking advantage of the areas with the least resistance. The rising of the magma toward the surface of the Earth and its eruption is what forms the Cascade Volcanic Arc above the subduction zone. This zone is an important geologic area prone to earthquakes, volcanic eruptions, and massive geologic shifts. That's why the seismic and geothermal activities have been closely monitored by researchers using advanced tools. Mount St Helens has been showing signs of reawakening after building itself for many years after the last eruptions. The signs were noticed in 2004, and more movements were seen 10 years later in 2014. However, recent disturbing findings were found in the surrounding oceans. Findings. The first time scientists became aware of the leak was during a routine underwater geological mapping in the year 2015, when thermal imaging scans picked up strange images that scientists were not accustomed to. The team of scientists from the University of Washington would later discover the leak directly on the 600-mile-long Cascadia subduction zone fault, and they've named it Pythia's Oasis after the Greek oracle and priestess of Delphi. As the scientists were preparing for a cruise, they experienced a delay due to weather conditions. Just then, the ship's sonar located strange bubbles on the surface of the ocean, but that was nothing compared to what they were about to uncover. With the help of a remotely operated robot sent to the spot leak spot, they were able to get a better view of what was actually going on. What they found was a leak seeping upwards from the floor of the Pacific Ocean and directly on top of the Cascadia subduction zone, around 80 kilometers off the coast of Oregon in the US. This is not just an ordinary leak. It's causing substantial concerns in the world of science, with reports suggesting it could cause a massive magnitude 9.0 earthquake, according to the Michigan Tech University's earthquake magnitude scale. Even more worrying is the fact that some of the findings at the leak area and its surroundings are not yet understood. For instance, an examination of the chemical compounds also revealed some rare isotopes that have long been associated with the Earth's crust. This may be a hint that the leak is connected deeply to the core of the planet. Some scientists are also suggesting that the leak may be a part of a much bigger natural occurrence, one which we're not yet familiar with. But what exactly is the composition of the leak, and what are the immediate and long-term implications? Leak composition.
Actually was above the surface of the sea. And at some point, that collapsed and went down into this deep basin called the Grenada Basin.
When the leak was discovered, it was originally thought to be water. They assumed it was a hydrothermal vent, which wasn't a strange sight near tectonic boundaries. Upon observation of the leaked content, it appeared hot, and researchers theorized that the Pacific leak was water leaking at a high temperature. Reports at the time suggested that the fluid was warmer than the surrounding ocean's water by 16 degrees Fahrenheit. However, more studies in the leak zone have revealed that this isn't the case. It is not simply hot water escaping the hot Earth's mantle. Instead, it is a warm tectonic lubricant containing concerning levels of carbon dioxide, methane, and other volcanic gases. It also had chemical compounds that tied it directly to the magma coming from beneath Mount St Helens. According to a paper published in the Journal of Science Advances, the liquid originates from the Cascadia megathrust, a boundary between two tectonic plates of our planet with temperatures ranging between 300 and 350 degrees Fahrenheit. The unique fluid, which is peculiar to the Cascadia, contains an extreme amount of boron and lithium, as well as depleted levels of chloride, magnesium, and potassium. Scientists can confirm that the leaking fluid is coming from mineral dehydration reactions and compaction of pore water, with temperatures ranging from 150 to 250 degrees Celsius. This is a unique combination of factors, and scientists have been able to trace the source to the plate boundary in central Oregon. The fluid is flowing at a rate of 10 to 30 centimeters per second, a magnitude higher than what's obtained in similar areas, and thought to be a result of extreme pressures along the plate boundary. With the seismogenic behavior of subduction zones heavily influenced by reactions between fluid and rock, flow of fluid and fluid pressure, scientists have been able to determine the cause of the leak. The pressure of fluid around the megathrust requires a balance between the incoming fluid sources and the outgoing flow of fluid. The pressure becomes extreme when the input rate is greater than the outgoing rate. Now let's take a look at the potential dangers that could arise from this leak and the impact each one could have on our well-being and the planet. Possible dangers.
The choking ash fills the air outside, turning the sky dark. Breathing becomes almost impossible.
Scientists are predicting extremely serious consequences as a result of this leak in the Pacific. They think it could even fuel a magnitude 9.0 earthquake known as the Big One, which will be the most powerful earthquake ever seen in the United States. In between the North American plate and the Juan de Fuca tectonic plate lies a megathrust, a large thrust fault or space within the Earth's crust, through which old rock particles are pushed up above the newly formed ones. A megathrust relies on fluid for smooth operation, but in this case, the fault is losing fluid and lowering the pressure between the plates. This will lead to friction and stress that develops into a magnitude 9.0 earthquake. And researchers are worried that a massive earthquake in this region could affect states like Seattle, Portman, Tacoma, Eugene, Oregon, and Washington, covering about 140 miles and affecting around 7 million people. An earthquake of that magnitude could trigger a massive tsunami similar to the Tohoku earthquake of 2011 that birthed the nuclear accident at Fukushima. It would also be the worst natural disaster to occur in North American history since the 2010 earthquake in Haiti, which killed over 100,000 people. Alert levels are going over the roof, and that's understanding. Already, we have seen similar occurrences that have given us a hint of the dangers that lurk if the leak were to lead to an earthquake. A similar incident happened in 1700, a magnitude 9.0 earthquake at the Cascadia subduction zone, and it was one of the most devastating earthquakes in recorded history. It struck Vancouver Island and gave rise to a tsunami that eliminated the winter village of the Pachena Bay people, killing everybody in the process. The 1700 earthquake and resulting tsunami also affected the United States West Coast, securing its position as the second most serious earthquake in the United States. What about the eruptions at Mount St Helens? If this leak leads to another major eruption of the mountain, It would bring about more serious consequences than the most serious one that happened in 1980, considering the location's increased population and infrastructure. However, there are even bigger concerns stemming from the connection between the leak and Mount St Helens. With the unpredictable migration of magma, as evidenced by findings related to this leak, volcanic activities could speed up in unexpected ways, not just at Mount St Helens, but also at the other volcanoes along the Cascadia subduction zone. According to volcanologists, there is the possibility of a chain reaction along the cascade, a series of connected volcanic explosions with one triggering another until all volcanoes along the cascade have been affected. This could spell devastating consequences in the form of eruptions and earthquakes, especially for cities like Vancouver, Seattle, and Portland, which are located in or close to the Pacific Northwest.
The National Disaster Management Agency is monitoring an increase in activities taking place at Kikimjeni, the region's only submarine volcano located between Grenada
And it actually was above the surface of the sea. And at some point, that collapsed and went down into this deep basin called the Grenada Basin. Right now, the small Kikimjeni.
This is a good time to talk about the sudden increase in seismic activity in an underwater volcano around Grenada. According to the Seismic Research Department at the University of West Indies, the underwater volcano known as Kikimjeni looks like it's reawakening with its observed activity increase, the biggest of which was recorded in February 2024. The volcano, which was first observed in 1939, has already erupted several times over the years. The current alert level of the region is yellow, informing an exclusion zone of at least 1.5 kilometers, while the National Disaster Management Agency, NADMA, monitors its activities. As for the leak near Mount St Helens, the United States Geological Survey, USGS, has assured of no immediate danger. Scientists still have time to conduct in-depth research to understand what's in stock as far as the leak is concerned. But make no mistake, relevant authorities and bodies are on their toes. Geologists are racing against time to understand the full extent of the leak, while emergency response teams keep working to perfect their evacuation plans. A megathrust earthquake remains on the cards because of the Cascadia subduction zone's proneness to such an event. Some experts believe North America is already due another one, and the leak will no doubt increase the fears. What effect will this leak have on the environment? How will humans and other organisms be affected by this leak? Let's find out. Effects on the environment.
Kikimjeni because we were there in 2003, so it's been about 10 years since the last time we were there.
Earthquakes and tsunamis are not the only dangers that could potentially stem from this leak. Some of the chemicals released, such as carbon dioxide and methane, have greenhouse effects. The current rate of release for these chemicals is indeed minimal. Compared to what's harming our planet, there is the possibility of a more substantial quantity in the future that could destabilize the Earth's balance. For instance, carbon dioxide is capable of trapping heat in the atmosphere, but methane is even more potent, about 80 times more dangerous than CO2. The presence of more leaks like this one, or an accelerated leak rate, could produce more methane gas than our atmosphere is capable of living with, spelling trouble for the Earth and its inhabitants. To aid in the assessment of the threat level, scientists need to find out if this leak is a one-off or a part of a connected group of leaks. Already, the ocean, especially areas surrounding the Cascadia subduction zone, has huge blocks of crystallized methane hydrate trapping methane in ice. These hydrate blocks are stable enough to pose no danger to the atmosphere at specific temperatures and pressures. A change in the conditions can cause the release of the methane, and the recent leak seems to be connected to one of these methane blocks. If the leak increases in rate, or taps into other methane blocks, that's more methane released into the air, but that's not the only concern. What if the leak maintains its current rate, but other geothermal or weather conditions interfere to set off surrounding methane blocks? That will likely lead to an unrestricted release of methane, global warming, and more methane release. Volcanic activities could also lead to the release of aerosols into the atmosphere. While this will cool the atmosphere temporarily by shielding the Earth from the heat of the sun, it will also destabilize weather conditions and affect agricultural activities. Expectedly, studies revealed a recognizable increase in the surrounding ocean temperatures. When combined with the affected chemical composition of the area, it's expected to produce a distinct marine life diverging from the well-known. Many species are already leaving the region in search of another place that looks like their preferred habitat. Surprisingly, some species are also migrating to the region. These may be organisms that favor high temperatures for their daily living and reproduction. But it's not all smooth sailing for these organisms. Natural occurrences like this leak tend to go hand in hand with sudden chemical and biological changes, which may be potentially hazardous for marine species that rely on stable environmental conditions. If this leak disrupts environmental factors on a substantial scale, we may be looking at mass die-offs of certain organisms and entire ecosystems. As the composition of the leak continues to hint at a diverse range of contributing factors, let's explore some of the other happenings that may have contributed to the leak and the impending dangers. Possible contributors. While most of the leak is likely a natural occurrence, or at least a combination of inadvertent happenings spanning many years, it is not out of place to consider the possibility of other occurrences that have given rise to the leak or hastened its coming. The first one is the Fukushima nuclear incident, which occurred in 2011 due to the Tohoku earthquake and tsunami in Fukushima, Japan. A 9.0 megathrust earthquake, the fourth most powerful ever witnessed on our planet, happened under the Pacific Ocean and triggered a tsunami that rose as high as 40.5 meters, or 133 feet. While the tsunami only lasted a couple of minutes, its effects were far-reaching and catastrophic in some regions. It resulted in the shutdown of various power plants due to electrical grid failure that damaged backup energy sources for the plants. As for Fukushima Daiichi, it was a meltdown. The core in 3 of the reactors at the nuclear power plant began overheating, leading to the discharge of radioactive contaminants into the surrounding areas. Contaminated waters from the power plant accident traveled into the Pacific Ocean, and it persisted for years. Authorities continued to pump 400 metric tons of coolant water into the reactors every day as of 2013, with contaminated water discharged back into the Pacific Ocean, despite protests and retaliation in some regions. In 2015, hundreds of metric tons of radioactive water, as well as contaminated soil, also escaped into the Pacific. 5 years after the accident, things looked like they were under control, especially with the construction of an ice wall helping to arrest the escape of contaminated water into the ocean. But scientific research showed that radiation was still finding its way into the Pacific Ocean. There's also the fact that contaminated water and soil persist on the grounds of the power plant, with the possibility of weather conditions and natural events moving some of them as far as the Pacific. Other factors that could have been contributory to the occurrence or speed up include more human-contributed happenings, like the grounded oil tanker, whose oil is leaking into the water. The Russian tanker moving 200,000 gallons of oil was forbidden from continuing movement in the Pacific, but it struck a reef and started leaking oil with images of oiled shorelines making their way online. The spill gave rise to various concerns from experts, with some saying the mixing together of these substances. The 1980 eruption on Mount St Helens is another event that may have contributed to this leak. The volcanic disaster is considered the most disastrous volcanic eruption to happen in the history of the US. It began on the 27th of March with volcanic explosions and the flow of hot volcanic matter before the major eruption occurred on the morning of May 18. Mount St Helens eruptions reduced hundreds of square miles into wastelands, culminating in a loss of over $1 billion in damages. The eruption resulted in the death of 57 individuals, including World War I veteran Harry R. Truman, volcanologist David A. Johnston, and photographers Reed Blackburn and Robert Landsberg. Thousands of animals were also killed in the disaster. To prevent such disastrous circumstances in the future, we must look for solutions and position ourselves better to deal with the impacts. But what exactly can be done? Let's explore the possible solutions. Finding solutions.
And the risk of future events at Kikumjeni. One of the objectives is to bring a special device on the ROV to sample the gases in situ and to analyze those gases.
While this is the first discovery of such a leak in the ocean, scientists think that there could be others like it, possibly close by. Advanced technologies have been deployed to collect samples, map the area, and monitor changes as they happen. Initial findings suggest that the leak may be increasing in intensity and widening in size. What these results suggest is that the magma reservoirs under the area are becoming unstable. We're expected to discover more leaks like this one in other tectonically active areas as climate changes accelerate movement in tectonic plates. Activities in some regions may even influence reactions in others. This underlines the need for global cooperation to support more scientific research and preparation for potential risks arising from these natural events. Research institutions from around the world and geological survey bodies must work together to better understand this leak. They must share resources, technologies, and findings to ensure no information is lost. More autonomous underwater vehicles, AUVs, and remotely operated vehicles, ROVs, may be needed to track everything that's happening around the leak, as well as collect samples that will help our understanding. One of the solutions that has been floated is the idea of containment technologies that allow scientists to collect the gases released from the leak. This will lessen the impact of the gases on the environment while allowing us to get more data on the composition. But the logistics required to achieve this will be immense, and how and where will the collected gases be stored? All these pose questions about humanity's role in the occurrences of these phenomena. Is there really anything we can do to influence the direction of these massive geologic happenings that have been going on for billions of years? Or are we just ordinary observers with no meaningful impact in the grand scheme of things? Perhaps we can key into our technology to redirect the direction of these events. Perhaps even our most advanced technologies stand no chance, and we have to pay more attention to advances that help us inhabit other planets. Maybe it will be helpful that we already know more about space than we do the ocean. Or maybe we just have to wait for it all to play out and use what's left of our scientific advances to pick up from there. As scientists continue to explore the ocean for similar leaks, with the hope of getting more understanding and helping us prepare better for what's to come, we're left to marvel at how huge our world is and how little we know of it. One thing is clear at this point: more questions continue to spring up faster than we're capable of getting answers. We can only hope it will not be too late before we arrive at the right ones. That's all we have for you today. Feel free to drop your thoughts for us in the comments. Like this video and check out others on our channel. Don't forget to subscribe and hit the notification button so you don't miss any of our awesome videos.